Exponent rules. First of all, we're going to talk about what happens when we're multiplying. 2 squared means 2 times 2. Notice that that says times, so I'm going to put times. 2 to the 4th means 1, 2, 3, 4 2's. So if you notice in the end, you have 1, 2, 3, 4, 5, 6. You have 2 to the 6th. Here I've got 4 x's, 1, 2, 3, 4. It says times, so I'm going to write times again. 1, 2, 3, 4, 5, 6, 7. Notice that here I kept all the 2's and I said I had 6 of them. The base doesn't change. Here my base is x. It's not going to change. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On this problem, the parentheses mean times. I have 3. But it is not raised to the 4th power. Only the w is. W is the base. 1, 2, 3, 4. Now, parentheses mean times, so I'm going to write a 2. And I have 1, 2, 3 w's. The w's are the base. Those are what have exponents. 3 times 2 is 6. That will change because it is not a base. It's not repeated. I have 1, 2, 3, 4, 5, 6, 7 of the base. 7 w's. Next problem, I have 5. The base here is A. I have 2 of those. Then the base is B, and I have 1, 2, 3, 4 times, that is a -2. A is only one of them, and I have 5 B's. 1, 2, 3, 4, 5. Now, again, 5 and -2 are not bases. They don't have any exponents. 5 times -2 is -10. I've got A as a base. 1, 2, 3. I have 3 A's. B's, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you look up here and you see what happened, 4 plus 2 is 6. 4 plus 7 is 11. 4 plus 3 is 7. 4 plus 5 gave me the 9 on the B. 2, that is a 1 for A. 2 plus 1 is 3. So my rule is when multiplying with, this is important, same base. Right here the base was A, so I added those. I didn't add all the exponents. I did not do 2 plus 4 plus 5. So when multiplying with the same base, add exponents. Now, a trick that I've taught my students is if you write down PEMDAS this way, and you know that stands parentheses, exponents, multiplication, division, addition, subtraction. Right now we are multiplying, so when I go to multiplication, one less operation would be to add. That's what I should be doing with its exponents. Okay, when we move over here for quotients, notice that 2 is the base, 2 is the base, and I've got 2 exponents. 1, 2, 3, 4, 5, 6, 7. I've got 1, 2, 3, 4, 5. Writing it out, anything divided by itself is 1. So those 2 divided by 2 become 1. If you notice, I have 2 2's, and they are in the numerator. So that's a 2 is the base squared because I have 2 of them. If you were to type this in your calculator, you know 2 squared is 4. So if I say 2 raised to the 7th, what was there? Yep, 2 raised to the 7th, enter. And I want to divide that by 2 raised to the 5th. Notice my answer is 4, which is 2 squared. Now, W's, 1, 2, 3, and I've got 1 in the denominator. Anything divided by itself is 1. So I have 2 W's left that are being multiplied, so that's W squared. Again, left in the numerator. Here I have 10 times B, and I have 7 of those. In the denominator I have 5, and times 3 B's. Anything divided by itself is 1. Now, 10 and 5 are not bases, so I'm going to divide. They are not exponents. They don't follow exponent rules. 10 divided by 5 is 2. I have 1, 2, 3, 4 b's left. Those are left in the numerator. Negative 30, 10 c's off. 1, 2, 3. And then I have 5 d's. I don't even know that they'll all fit up here. And in the denominator, I have 2 c's and 3 d's. So anything divided by itself is 1. And I have 3 d's, 1, 2, 3, 1, 2, 3. Negative 30 divided by 10 is negative 3 in the numerator. I have 1, 2, 3, 4, 5, 6, 7 c's left in the numerator. Notice I have no c's in the denominator. I have 2 d's left in the numerator. None of them are left in the denominator. So when I look here, 7 minus 5 is 2. 3 minus 1 is 2. 7 minus 3 is 4. 10 minus 2 is, 1, 2, 3, 4, 5, 6, 7, 8. See how I can check? I didn't count them right. I should have 8 c's left. 5 minus 3 is 2. So my rule, when dividing with, again, the same base, that means I didn't take the c's, 10, and minus 3 on the d. Bases have to match. Same base, subtract your exponents. Now, again, I can go back to my PEMDAS rule. If you look here, here I am dividing. One less operation is to subtract your exponents. Okay, we have another set of rules we need to follow. I would like to do this one. So now we have exponent raised to another exponent. So I have 2 times 2 inside, but I want to write that 4 times. So there's once, there's twice, 3 times, 4 times. I have written 2 squared 4 times. Everybody's being multiplied, so I have 1, 2, 3, 4, 5, 6, 7, 8. 2, that's my base, raised to the 8th. I've got 3 x's, 1, 2, 3. I wrote that 4 times because it asked me to write it 4 times. I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. X to the 12th. Again, the base doesn't change. I have y to the 7th, but I'm not supposed to write that at all. I'm going to come back to that one because we're going to do the 0 exponent in a second. Here, I have 3 with 4 n's and 3 p's. And I'm supposed to write that twice. So I'm going to write it again. Now, notice what many students do is 3 times 2. 3 is not an exponent. I have 3 squared, known as 3 times 3, which is 9. I have 4 n's, and 4 n's. When I count those up, 4 and 4 is 8 of them. And I have 3 p's and 3 p's, a total of 6 p's. Now, on your PEMDAS rule, this also works here. Right now I have an exponent raised to another exponent, so I'm here. One less operation is to multiply. Notice 4 times 2 is 8. 3 times 4 is 12. 4 times 2, they're both exponents, so I can multiply them, is 8. 3 times 2 is 6. This is not an exponent. I do not do 3 times 2. That is 3 squared. So my rule says when raising an exponent to an exponent, multiply exponents. Again, notice it's all about exponents. When raising an exponent to an exponent, multiply exponents, not an exponent. Don't multiply it. We'll come back and do those examples in a second, because we need to talk about this guy. What happens? Let's do 0 power first. When I do this, my rule, if I follow this guy, right now is I'm dividing. So one less operation is to subtract. Well, 4 minus 4 is 0. So let's see what happens. 1, 2, 3, 4. 2. Notice 1, 1, 1, 1. Well, all those ones, when I multiply them, are 1. I will prove to you, the calculator will tell you, 2 raised to the 0 power. It's 1. Let's try this guy. Z, 1, 2, 3. 1, 2, 3. Again, anything divided by itself is 1. So this is z to the 0, which is 1. 3 minus 3 is 0. But anything to the 0 power means everybody divided evenly, so we have 1 left. Now we have 8 over 2, which we're going to deal with first. 8 divided by 2 is 4, so I'm going to put a 4 here. When I have these n's, that is n to the negative 4 minus a negative 4, because we're subtracting, dividing, subtract. That really becomes a plus, which means negative 4 plus 4 is n to the 0. You can see one will cancel the other. They're the same thing. So what you need to know is n to the 0 is 1. 4 isn't raised to the 0, so my final answer is 4 here. 4 is not raised to the 0. This is 1. 4 stayed. Now you can look right here, and you know that 4 divided by 4 is 1. W times W, W times W. 1, 1. Well, everybody canceled one another out. They all became 1. So my rule says anything to the 0 power equals 1. Always. Notice the 4 wasn't to the 0 power, only the n was, so 4 doesn't change. That means that when I go back over here to this example, anything to the 0 power 7 times 0 is 0, so my answer must be 1 here. I'm multiplying, because I had exponent to an exponent, I'm multiplying them. 7 times 0 is 0. Anything to the 0 power is 1. Okay, last and final rule, which is probably the most complicated. Right now, I know from earlier that it said when dividing, subtract my exponents. Sorry, when dividing, subtract the exponents. Well, that being said, when I look here and I subtract 5 minus 8 is a negative 3. So let's look at what that would be. 1, 2, 3, 4, 5. Okay, anything divided by itself, we know, is 1. How many do I have left? I have 3 of them. But they are in the denominator. So when I write the 2 as the base, I have to put this in the denominator. Now, that being said, when I have a negative exponent, I need to move it. I'll explain that in a second. These were left in the denominator. Here I have 3 k's, and I have 8. Anything divided by itself is 1. Notice I have 1, 2, 3, 4, 5 k's left. And again, they are in the denominator. I have to leave them there. If I had done my math, 3 minus 8 is a negative 5. So that tells me negative exponent means move. I did 3 minus 8. So the negative 5 was in the numerator, put it in the denominator. Here I got 25, 1, 2, 3, 4. And I've got 5, 1, 2, 3, 4. Oh, I can't write all those 10s out. Now,